Welcome back to our series of solution and explanation to competitive coding. Today we are going to solve LeetCode question number 2079, which is watering plants. So let's check what the question says. You want to water n plants in your garden with a watering can. The plants are arranged in a row and labeled from 0 to n-1 from left to right, where ith plant is located at x equals I. The reverse is at x equals -1 that you can refill your watering can at. Okay, so we are given we have to water our plants in our garden, and all the plants are like arranged in a row and indexed from 0 to n-1. That is, planted in index 0 is labeled as 0, and so on. So, and at index x equals -1, that is just before the first plant, there is a river where we can fill our watering can. Each plant need a specific amount of water. You will water the plant in the following way. So, like each plant didn't, all the plants didn't require the same. It might be the case, but they require a different amount of water in the case. Okay, so there are some rules to plant a water. So let us check what the rules are. Give me okay. So for the first rule, it says that water the plant in order from left to right. So suppose if these are our plants, so we have to water them in like left to right manner. We can't just randomly water any plant. We have to start from left and move to right by watering. After watering the current plant, if you don't have enough water to completely water the next plant, return to the river to fully refill the watering can. Okay. Second rule is that we can't just move on watering plant until we ran out of water. What we have to do, we have to check whether our next plant, what the amount of water required by the next plant, we are left with that amount of water. If not, we have to return to our river to fully refill the watering can and then come back to the plant and water the plant completely at once. Okay, this is the second rule. The third rule is you cannot refill the watering can early. So this is kind of another restriction. So we can do this like suppose we are on the plant 1 and we water that plant, and now we have enough water to plant this next water the next plant, but we can't do we don't move ahead and water that plant. We move back to the river, refill our can fully, and then we can't do this. We can't move back to the river unless we are not left with enough water to water the next plant. Okay, so you are initially at the river, that is x equals -1. We are initially on the river with our water can with the position -1. It takes one step to move one unit on the x-axis, and it takes one step to move to the next plant, okay, to water it. Given a zero index integer array plants of an integer where plant of I is the amount of water the ith plants need. So we are given an array of integer where each element of array uh, indicates the amount of water a plant needs. Okay, and the capacity and the integer capacity representing the watering can capacity, and we have given the capacity, the amount of water in watering can hold at a time, at a moment. Okay, return the number of steps need to water all the plants. So we have to return the number of steps to water all the plants. So suppose we are on this, and initially we are on the river. They told us, okay, and we have our watering can. Okay, we have our watering can. So initially we are at river. Now we fill our watering can with 5 unit capacity of water, 5 units of water. We move to this plant and then we water it, and our 2 unit reduced. We move to this plant and again we have to water it, give it 2 units. Now we are left with 1 unit. We can't move and put 1 unit in this. We have to move back to river to refill it completely, and then again move back to this plant, water is 3 unit, and again we are left with 2 units. We can't move ahead. We have to go back and refill it completely and then water it. So we now we are done. Yeah, so the number of steps in this will be initially we want one step, like one step to move here. Okay, oh, one step to move here, and 2 step again, the second step to move here. Now we can't move ahead, we have to go back, because we don't left with 3 units of water. So third step to move back to this, and again fourth step to refill our can. So on we'll go forth and forward and backward, and at the last, like 4 step, then 5, 6, 7 step for this plant water, and then again 8, 9, 10 step, 11, 12, 13 and 14. Each finally we'll need 14 steps to water our plants. So how will it work? Let us suppose, so each time we are on the plant, we have to check whether we have left with enough water to water our next plant. In the other sense, we can do that. Suppose we reach this plant. Now what we have to do is that we recognize, or we realize that we don't have left with enough water to completely fill the plant. So what we have to do, we have to add the number of steps. Like we by standing here, we add the number of steps. We'll go back and come to this plant and add those steps to the step what we have already taken to reach here, or what we have already taken to reach here, and add the number of steps -1 to go back to watering to river, and come back -1, because we are not initially here. The question says that you are here and you recognize that you don't have left with enough water to fill this. So what we have to do, we have to calculate the number of steps we have to take to reach at this step, and double the amount of step from this position to river, and add 1 to it, and now we can reach this step and reduce our capacity to capacity of the watering can minus the amount of water required by this position. We can do each time this, so in order to get the total number of steps. If it is not clear, let me code so that you can properly understand what I'm trying to say. Okay, so suppose we have to do a little bit trickier here, that if we have only one step, if we have only one plant, so it would be code would be quicker. But suppose initially our steps equal 0, integer se steps equals 0. Okay, and suppose our next variable is like cap, what is telling the temporary capacity of what is telling, or remaining water, we can say remaining. This variable is telling us that the amount of water remaining in our can. So initially it is like capacity, because we are on the river, we have recently filled it. Okay, capacity. Now we have to iterate over each plant to check to water them. For int I equals 0 and I is less than plants dot length, and then I plus plus. Okay, so now if we are entered this situation, we have to first check whether our container or watering can have enough water plant or not. If our remaining capacity is greater than or equals to plant of I, that is amount of plants is, yes, okay, plants of I. If this is the case, that is our remaining capacity is greater than, we have to simply just water it. That is, we have to move steps plus plus, and our capacity, that is remaining water, will be decreased. Supply plants of I. Okay, but suppose this is not the case, and we don't have enough water. So what we have to do is we have to add some extra steps. That is int extra equals whatever the index we are on, like times 2, because here we can see we are doubling not this index, because we reach this step whatever is given by this index, because index are starting from 0, not from 1. So to reach this steps, we want these to reach this index, we want this much steps. So we are doubling these steps, not these steps. Okay, or we can do like index I minus 1 plus 1 index. That will be insane for the sake. Okay, so int extra equals to I times 2. Okay, these are the amount of steps we require to go back and then come back. And what we'll do is our STE steps will become steps plus extra bad plus 1. Okay, we need one extra step to now move forward. Okay, the steps will become extra plus 1. Okay, and our capacity will now be okay, or remaining capacity remaining equals capacity minus plans of I. And now we can return our steps. Let me check if it works or not, or if there were some typos. It did work. Now let me submit our code. And it is 48% faster, like it is kind of midway through. Okay, so hope you enjoy learning, and if you have better solution or any other suggestions, you can comment down below. And again, thanks for watching.